Hello guys, this is Mr. Yaya. So if you think an AI project is just preparing the input data, choosing the model, and then training, so you are wrong. One of the most important things in AI projects is you need to understand the task, the data features. As they say, the student is only as good as his teacher. For example, in this episode, we will talk about the cough sound classification. What is like in the cough mechanism and what are the main differences between them? The energy, the frequency, or the duration of the cough. Let's find out. And at the end of this video, I will talk about how to use the deep learning model CRNN in classifying COVID-19 patients. If you like this video and find this helpful for you, please like, comment, and subscribe for more.
First thing first, we need to understand the lung anatomy. So the lung is we have two main parts of the lung is the airway like a pipeline and the air sac like a balloon. The airway here we got trachea and bronchi, two bronchi, and the bronchi is further separated into bronchioles, which you can see right here. And at the end of bronchioles, we got the air sac called alveoli, and on the surface of alveoli is the blood capillaries, which are responsible for the oxygen exchange into the blood. Okay, and we see the red. The first is the cough mechanism. So on the surface of trachea here, we got something called the muscular cells, and those cells are like the hair, which can recognize the strange protein on the surface of the bacteria, fungi, or the virus. So after that, they transmit a signal through the vagus nerve to the medulla of the brain, and then the brain will trigger the cough mechanism. So that's the first phase, the receptorial phase. So the next steps are the inspiratory phase, which are we will breathe in additional air. So usually about 50% of the lung capacity. Secondly, the epiglottis will close, and then simultaneously our abdominal and the rib muscles will compress, like our hands compress the balloon. So it will increase the pressure. That called the compressive phase. And lastly, the epiglottis suddenly open and let all the air through the vocal cord and create the rushing sound called cough. That is the expiratory phase. So the velocity of air can be up to 100 miles per hour. It's faster than a basketball. Okay, that's the cough mechanism. So the cough sounds in different diseases. So we remember that the lung have two main parts, the airway and the air sacs. So it leads to the four main problems. For the airways, we got a narrowed and widened airway. For air sac, we got a stiff lung and fluid-filled lung. Okay, the normal airway, so as you can see that the flow of air is easy to move in and easy to move out without any interruption. So, and the sound typically have two sounds. And the first sound is big, the second sound is smaller. The average duration is low compared to other sounds created by disorders. So, for example, two sounds, and the energy is quite constant. With narrowed airways, so narrowed airways is usually because of the accumulation of the mucus right here, or the inflammation of the muscles right here. So it's hard to breathe. And usually within one inspiratory phase, we got multiple cough bounds. After that, like 2 or 3 strong cough bounds. The energy distribution is quite high compared to other disorders. So you know that the sound is, the energy is quite high because we got narrowed airway. Narrowed airway means the higher pressure, means the higher energy, and mean the bigger sounds. Okay, the widened airway here is because of the damage on the surface of the pipeline, which is the trachea, and the mucus usually form to pull here. So we usually have wet cough. So here we got dry cough without sputum, and wet cough we got sputum. And the widened airway means that we have the lower pressure. So the first cough sound is usually big to clear the airway, and 2 or 3 small cough bounds after that is small. And we got here the stiff lung. Stiff lung means that the lung will not, that flexibly expand to get additional air. So we cannot get a deep breath in. And secondly, the scarring on the surface of the lung right here is really hard to exchange the oxygen into the blood, which means that we don't have enough oxygen to our brain, our kidneys, and other organs. So yes, we have something like the brain and the kidneys not properly working. That's the second thing. The breath, we don't have the deep breath in. So not deep breath in means we not enough the pressure. So it means that the cough sound is not really big. So the energy distribution of the cough is the lowest compared to other disorders. The average duration is longer, like you have multiple weak cough bounds. Okay, so like just like that. Okay, so the fluid-filled lungs right here, the fluid mean the bacterial waste. Oh, I'm sorry, that the stiff lungs right here is because of the weaknesses of the respiratory muscles. Okay, so the fluid-filled lungs right here, we still have the same with stiff lungs, so it's hard to exchange the oxygen into the blood. We don't have the deep breath in, but the energy distribution is gradually decreased. The first cough bout is strong, but the second cough bout is weak and is gradually weaker. And the list with the last cough bout. So what about with the COVID-19 cough sound? So actually the COVID-19 cough sound is not really different from other disorders, but we can classify it with our ear. But some of the paper and some of the work have proven that the machine can understand and the machine can classify the COVID-19 cough sound. But the whole idea is to classify the cough sound. We need to based on the sound of the breath, the energy of the breath, the energy of the cough sequence, the duration of the cough sequence, and anything about the time series data. So the best model that I come across is CRNN because they are really working well with the series data. Let's first talk about the data. The data right here, I use a lot of things like nerve frequency, spectrogram from MFCC's spectral centroid, spectral bandwidth, runoff ZCR energy. So I got all the primary features right here, and I stack them up like image. You can see that's the male spectrogram right here, MFCCs, and all of the 1D features right here. So all of the data is on the time axis, and from there we can use CNN to extract the feature from the image. So let's go to the model. The first is CRNN. I use the CRNN of VGG16 to extract the feature from the image, and after that I use attention mechanism to learn when is the important features to understand. And the BiLSTM right here is really working well with series data. So why BiLSTM and not RNN? Because RNN has some drawbacks with vanishing gradient and exploding gradient, but LSTM means long short-term memory, and they will fix that drawbacks. We have BiLSTM, which means we can use the previous information and the subsequent information to update for the current information. And last, I use a fully connected layer to classify information into COVID-19 or non-COVID-19 patient.